Hi everyone, welcome back to my channel Success Maths. Today I'm going to show you the real difference in meaning between fraction plus fraction and fraction multiplied by fraction. I understand many of you will know, fraction plus fraction, I will know how to do it to find the final answer. Likewise for fraction times fraction. But do you know when do we add, subtract and multiply fractions in real world problems? So let's find out. So if you're going to do fraction plus fraction, what would you do? Many of you will know to make the denominator the same. So for 3 and 2, you need to make a common multiple, which is 6. So for this case, you multiply this by 2 and you multiply the top by 2 as well. For half, you multiply this by 3 and you multiply this by 3. And in the end, you get 2 out of 6 plus 3 out of 6. And the answer is 5 out of 6. However, do you know why? Do you need to make the denominator the same? That is an important question that you must ask yourself why. Then from there, you will understand when do you need to use addition of fraction or subtraction of fractions in word problems. So let's move on to the next question on fraction times fraction first before we talk about it in a word problem. So let's talk about fraction times fraction. So for this case here, you know you need to multiply the 2 numerator and also the 2 denominator. 1 times 1 is 1, 3 times 2 is 6, and there's the answer. Then again, have you ever thought why? Why do we multiply the 2 numerators and the 2 denominators together to get the answer? Okay, so that is an important question that you must ask yourself. I know many of you will just say, okay, I will just multiply the 2 numerators and the 2 denominators to get the answer. However, you need to know when do you need to do this and multiplication of fractions and addition of fractions in word problems. So in my next slide, I will show you an example of a word problem. For example, now you take a look. Tom had some marbles. He lost half of his marbles during the game. He then gave 1/3 of his marbles to his sister. What fractions of the marbles was left? First, you must know there are 2 fractions here. And you must always remember in any word problem, you must check whether the 2 fractions are they referring to the same whole. So for this case here, you know this 1 goes to the loss, 2 goes to his marbles. So he's gone with 2 out of 2. He actually lost 1 during the game. Then he then gave 1/3 of his marbles to his sister. Again, 1 goes to the gave. He gave 1 to the sister, and 3 is actually also talking of his marbles. So what fraction of his marbles was left? So you must remember, these 2 fractions, are we going to multiply or are we going to add or subtract? First of all, you must always check whether the 2 fractions are they referring to the same whole, or in other words, is the 2 denominator refers to the same whole. So if I'm going to draw a model, it will look like that. The 2 marbles, he lost half of it. So half of this is gone. So normally when we shade, what are we shading? We are shading the numerator part, which is you learn in primary 2. Next, he lost 1/3 of his marbles to his, gave 1/3 of his marbles to his sister. So he gave 1/3 to his sister. So this was given away. This was also given away. So what the question asks, what fraction of his marbles was left? His fraction of his marbles means going back to his whole, exactly what was left. So what you normally do in this case here, the 2 fractions are referring to the same whole. I'm sure you all will know, actually make the denominator the same. So when we make the denominator the same, what actually is happening in the model? So let's find out. So I want to find out how many marbles or what fraction of marbles were given away. So you know you need to add half plus 1/3. In a previous slide, you know you need to multiply this by 3, multiply this by 3, multiply this by 2, and multiply this by 2. then you have 3 over 6. Then plus 2 over 6. That will give you 5 over 6. So actually what happens in the model, it looks like this. So for the half, you actually multiply by 3. What does it mean? It actually cut each into 3. 1, 2, 3, and the other half also must cut into 3. That's why in the end you have 6 overall. Then what about the second denominator, which is the 3? In the second model, when I multiply this by 2, actually what is happening here, you also cut each into 2 each. Alright, when you cut this into 2 each, you also will get 2 out of 6, which is the shaded part. So in the end, the total number of marbles or fraction of his marbles were gone from his own set of marbles at first is 5 out of 6, which means this 2 is actually can be shaded and put in here. So in other words, what was left is this portion here. So the 1 whole represents the marbles minus 5 over 6, which is the fraction of his marbles that was given away or lost. Answer is 1 over 6. So that's the answer. So this is an important concept that you must realize, that actually the addition of fractions or subtraction of fractions is closely related to model drawing. Okay, so with that, let's move on to the next question to see when do we use fraction multiplied by fraction. Tom had some marbles. He lost half of his marbles during the game. Lost half of his marbles, again is lost half of his marbles during the game. He then lost 1/3 of the remaining, gave 1/3 remaining to his sister. What fraction of marbles was left? So with that, you realize that this fraction here is not talking about the marbles, in fact it's talking about the remainder. So actually these two fractions are not referring to the same whole. Okay, so it is not referring to the same whole. One is referring to his marble, which is half, and the other 1/3 is referring to the remainder. So how would the model be like? First, lost during the game, and actually the 1/3 here is talking about the remainder, which is here, the remainder. So with that, I want everyone to take a look. This remainder should cut into 3, and his 1/3 is given away to his sister. So now you realize you are not going to add or subtract the fractions, because half is talking about the whole, the big whole, which is the marbles, and 1/3 is talking about the remainder, but remainder is part of the bigger whole. And with that, you will understand that what fraction of the marbles was left, which is this portion here. So if you remember in the previous question, when you make the denominator the same, you're actually trying to subdivide to cut to make unit size the same. So we do likewise for this, because this represents the same as the one below. So I'll cut this into 3 as well, and I'll cut this into 3. Bearing in mind, when you make the unit size the same, we revert back to the models, which is the total number of marbles, the original model, which I'm going to put this back here for the sister. Okay, so what fraction of his marbles was left? So the fraction of marbles here, we're talking about the original total. So from here, you know you left with 1 and 2. So it's actually 2 out of 6, which is equal to 1/3. But how do we calculate this using the fraction way, in the calculation way? So what we can see here is half of the marbles was gone, and the other half of the marbles was left. Then this half here, alright, you know that 1/3 of the half is given to the sister. So actually, what fraction of the marbles was given to the sister is 1/6 of the marbles was given to the sister. Then you realize these two fractions of the marbles left and all 1/6 of the marbles are referring to the same whole. So in other words, half of the marbles were also gone, right? lost during the game. So now we want to take a look what fraction of the marbles was left. So you can find out is that in total number of marbles that are gone is actually half plus 1/6. When you multiply this to make the denominator the same, because both fractions are referring to the same whole, then what is left is 1 minus 4/6. That will give you 2 out of 6, which can be seen in the model here. And you simplify it, divide by 2, divided by 2, you get 1/3. So you must know, when do we multiply? Actually, we multiply when they are not referring to the same whole, but the smaller whole is actually part of the bigger whole, as you can see here. This one I call it the smaller whole. This one is called the bigger whole, which is the marbles. Okay, so now I have more or less explained to you the fraction plus fraction, when do we do that, and fraction times fraction in word problems. Okay, so before I complete the whole lesson today, I hope you can actually support the channel by dropping a like and subscribe to the channel if you have not done so. Okay, alright, I hope today you have learned something. Alright, bye bye.